Karl Seiler. My company is PIVIT. I'm what I call an applied AI guy. For me, it all started back in the firing room for Space Shuttle #1, where we had just a math model at the time as opposed to the actual hardware. From there, I went and worked on nuclear power plant control rooms after 3 Mile Island blew up. The government said, automate this. That was interesting and fun. After that, my cousin and I started an interesting company called Level 5, and we were the leading provider of expert systems through the late 80s and up into around 2000. Expert systems, rule-based, think of it as a cloud of rule-of-the-thumb, notional if-then-else clauses that experts typically talk to people about. You know, if you see this and this or that and this, then we can conclude that. So they would just write thought clouds of if-then-else statements. We'd run that through our own compiler and then turn it into a dialectic application that would interview you and then come up with a conclusion. And that was used by the US Bureau of Mines and the National Institute of Standards and E.I. DuPont to design bottles and Bethel and Steel to roll plate and on and on and on. About 30,000 applications. From there, I worked for information builders and created a product line called Smart Mode, which was, as far as I can tell, the first commercial machine learning application. It monitored all the SQL statements coming into big data, enterprise data warehouses, looked for certain patterns, and then made predictions about the impact that would have to the server farm. After that, I did a .com called Scorecard USA, right here in Orlando, where we did amateur athletic sports statistics using some of the same technology to look for clusters in cohorts. You know, who are people the same age, sex, and prowess as me who are running these distances? Where am I at in that band? And coaches could use it to put together a little league team and Pop Warner team. And that was a lot of fun. I really enjoyed that. Once again, applying AI cluster analysis to look for things in sports. And because we were sitting on all of this sports traffic information, we knew what to try and sell you. I knew what kind of runner you were, so I could sell you a certain kind of sneaker, and I could actually predict when your shoes were wearing out, that kind of stuff. From there, I went and worked with Navtech, which was then acquired by Nokia, and we were the leading digital nav map company in the world for quite some time. And all automobile manufacturers, those maps were our maps, Yahoo Maps, MapQuest Maps, and then a group spun out, and that became Google Maps. So a lot of knowledge drain went out of Navtech and into Google. From there, I worked for a company called Modus Operandi on intelligent agents for the Department of Defense using semantic graph analysis, looking for bad guys in big networks of heterogeneous information. Most recently, I've been working with a group. We created a new company called Zontal, and it's in the big pharma R&D life sciences labs, taking all of the Internet of Things data streams that are coming out of these labs and encapsulating the data into a self-describing format. It's our fundamental belief that data should be able to describe itself, and these packets of data are actually designed by NASA, and it's in the same format that's used by the deep space probes, which are long, big amounts of information that are transmitted over flaky networks and that are very faulty. They're self-describing, so if somebody picks it up, they can take it apart and look at it. So our point is to make data usable 50 years into the future, long after the vendor's gone, the machine's gone, the operating system is gone, the environment that created it is gone, the data itself can still describe itself. So, I've been doing AI, applied AI for a long time, but I've been wanting to talk about this topic for quite some time. It's very germane right now, and let's just get into it. Go for it. About that. So, what is AI? I don't really want to get into a big semantic discussion. Oh, by the way, we're a small, intimate group here. Please don't hesitate to ask questions. Don't wait to the end. Anytime it was good. But basically, it's when a machine mimics the cognitive capabilities and functions of human. Usually, it's associated with some learning capability and some problem-solving capability. AI is just algorithms, dudes. So we live in this age of the algorithm. And decisions that affect your life on a daily basis are being made by ever increasingly sophisticated math models that surround you. A lot of times when people think about AI, they think it's something that's coming. You've been using AI for 20 years, and especially in the last 10 years, and remarkably so in the last 5 years. And that's not slowing down. Anytime you buy a product recommended, that's AI. Anytime Pandora puts together a playlist for you, that's AI. Netflix uses AI to give you its recommendation profile. Siri is all based on AI. Of course, Tesla's highway hands-free is AI. The Department of Defense is way down this road in automating certain defense and security, as well as exoskeleton-driven AI constructs. Have you ever used search? All search in Google is facilitated by AI algorithms. The stock market, automated trading, is largely run by AI. And it can shut down the market, these perturbations and these fast trades. Have you ever been audited? That was AI, watching for audit flags. Certainly manufacturing robotics is AI, and your credit score is determined by AI. I could go on all day long. You're surrounded by AI, you use it all day long, that's not slowing down.
Do you feel like the perception, though, of what AI means to the general public versus, because those were all like the computer science definition of AI. I don't think it aligns with what the general public thinks AI is.
Yeah, so let's fix that.
Yeah.
Right? Because AI are just algorithms that mimic human cognition. And let me put it this way, why now, right? Why do we see this kind of exponential acceleration in the adoption of AI technologies? It's really three things. One is, there's a lot more cheap compute power now than there ever was, so we can crunch the hell out of stuff. Number two is, there's a lot more data now than there ever was, and that's not going to slow down at all. It's going to vastly speed up. So, first thing I usually ask people when they want to do an AI project is how much data you got. Because if you don't have much data, then you're hard-coding knowledge, and it's crisp and brittle. If you have a big corpus, then we get happy. We've got stuff to deal with. And then the algorithms haven't stopped, right? The stuff that's been coming out of the research institutes in terms of algorithmic supervised and unsupervised machine learning is really remarkable. The deep learning breakthroughs that we've had in the last 5 years, the work that's been done by the IBM Watson group has been really phenomenal. So we've kind of tipped a curve. It's like a natural language processing. It's been around for a long time, but it was kind of crappy. Yeah. And we only have a certain tolerance point that's up about 82%. If you get over 82%, it's like, hey, this works. Yeah. Right? That's kind of what's happened with AI. We've got over that hump, and it works most of the time good enough. Yeah. Right? So I'm going to talk to you a little bit about the good and the bad and the ugly. Good things about AI and why we care and why it's proliferating. The bad things about AI and some of the ugly stuff that is starting to surface already. So why do this? One is it's precise. It's precision. Machines can do the same thing over and over and over again very, very, very precisely. That's why they dominate in manufacturing. They make the same exact weld tens of thousands of times with very little deviation, right? And they're also more reliable. They don't get drunk. They don't get sleepy, right? They don't get depressed, right? It's consistent behavior. And when it's bad, it's a bug, and we can fix it. And from that point forward, we've remedied something. So it tends to not slide back. So it's precise. Machines are very precise, and machines are more reliable. And in fact, in the AI world, we often look for constrained environments where we can be precise, right? So if you look at the automation pushes in the transport sector, the first breakouts are not the open road, which Google went after. Very, very hard problem to solve. They're really going to deploy first in closed campuses, a school campus, an assisted living facility, a Disneyland park kind of thing where it's a repeatable route. The people that I've run into in the transportation sector that are all over this, are the bus guys, the waste management people, and the truck convoyers, right? They can put 6 trucks on a highway 6 feet apart, blasting down the highway in the middle of the night. And the guys in the middle are asleep, right? They can go off the clock, because that's a real hindrance to the trucking company, because they can only drive for so many hours. And plus, what does it do? It saves money, right? 15% of their cost profile is in gasoline, is in fuel costs. So get a big slipstream going, that big tube of trucks going down the road, they save tons of money. You move the needle on these big scales, just 1 or 2%, you're good. You just save millions and millions of dollars. You certainly underwrote the effort. So there's a lot of cost savings that are driving these things. And the cost savings are primarily come from an optimization of a process. Think about long chain logistics. We only want to make just enough stuff just when we have to make it and deliver it, right? So, you know, the smart city, smart care, smart office, all of that stuff is optimization. And because there's so many variables to assess, to come to the decision to make the tweak that does the optimization, that exceeds our human capacity to kind of operate it in that many dimensions at the same time faster. So speed, safety is a big issue, trying to get people out of harm's way. The robot that'll go in and defuse the bomb, or, you know, take out the sniper, or, you know, there's a toxic spill, we send in these robotic agents. And the robotic agents, sometimes they can be remote controlled, but sometimes it's not fast enough. The local sensor pool has to be done in near real time so that they can navigate around the device. Obviously, the Department of Defense is way down this road. Think about probes, and, you know, arguably next-gen warfare is done robot to robot. And speed. Think about the electric grid. The management of very, very big, complicated, interconnected networks cannot be managed efficiently as the machines can do in the speed of time that they can do it. So they can take hundreds of thousands of variables and do an algorithmic assessment and make a minuscule tweak, but that of course adds up over time into improved safety, improved precision, improved reliability, and cost savings. So those are the drivers, and I maintain those drivers are so economically significant that I don't think anything stops it, right? It will exceed the capacity of regulation and governments to control it. It's just too much, it's worth too much money. So this is going, you know, when we think about AI, we often think about things like Amazon, Alexa, and that's really cool, but that's not really where it's happening, right? It's happening at an industrial scale. So, you know, for a long time, you know, when I talk to people about applied AI, the things that we're working on are quite often pretty mundane. You know, it's like helping you pick the right annuity, right? Pretty dull. But increasingly, as we've pushed more decision-making algorithms into the control sector, and the scope of those decisions and the impact those decisions have on humanity, you know, people start to ask us practitioners in the AI space, are you building Skynet? Are you building the Terminator? Are you building the Matrix? And the answer is fundamentally yes. We're working on it. You know, we are. You know. Well, where does that lead? You know, where does that logically go? And that was my impetus for going down this road and exploring these ideas. And, you know, some of the smartest people in the world whose jobs it is to think over the horizon are concerned, right? You know, Stephen Hawking said that the success in creating AI would be the biggest event in human history. Unfortunately, it may also be the last. Unless we learn how to avoid the risk, in the near term, world militaries are considering autonomous weapon systems that can choose and eliminate targets humans limited by slow biological evolution can't compete and will be superseded by AI. So a lot of this is driven by the concerns of the rate of change of growth and by the impending singularities, which we'll talk about in a little bit. Gates. I'm in the camp that is concerned about superintelligence. First, the machines will do a lot of the jobs for us. and not be super intelligent, and that should be positive. We manage it well. A few decades later after that, though, the intelligence is strong enough to be a concern. And I agree with Elon Musk and some of the others on this, and don't understand why some people are not concerned. Right? A lot of people are practically just heads down. But we are approaching a turning point. And these guys who live out there on the hairy edge and are pushing to get us to Mars, for example, are concerned. And we want to plumb the depths of their concern. So Elon Musk wades in and says AI is our greatest existential threat. I'm increasingly inclined to think that there should be some regulatory oversight, maybe at the national and international level, just to make sure that we don't do something very foolish, speaking of Tesla. And I think there is potentially a dangerous outcome there, referring to Google's DeepMind, which he invested in a way, kind of to keep an eye on. And then there's Ray. I love Ray. He's always out there. And on the positive side, and I actually agree with this as well, as we have the opportunity in the decades ahead to make major strides in addressing the grand challenges of humanity. AI will be the pivotal technology in achieving this progress. We have a moral imperative to realize this promise while controlling the peril. It won't be the first time we've succeeded in doing this. So the case that Kurzweil is making is, as the world gets increasingly connected and complicated and data rich, that we will become increasingly dependent upon these kinds of technologies to actually make it work, to pull it off, and to solve the problems at the scale that we're going to be faced with. So he's looking at it as a saving force, but with governance required. So, you know, you want to peel back the onion skin there a little too. What's freaking these guys out? And I boil this down to it's all changing so fast. You know, we work in human scales, right? And if we look at technological innovation over a long span of time, going back 10,000 years to the invention of agriculture, mathematics, railroads, telephone, penicillin, DNA, nuclear engine, and PC, well, you live here. You're the generation that lives here. It's going straight up, right? I had the unique opportunity to talk to Margaret Mead once, and she told an incredible story about her grandmother and what the world of change was to her grandmother. Her grandmother lived through a period of intense change, and then Margaret also lived through a period of increasingly intense change, and she compared the rate of changes, the amount of changes that her grandmother's generation saw and what she saw. And then if I think about my own generation, you know, the jet, the TV, the computer, the internet, that all just happened, right? And it ain't slowing down, so your kids' world of change will be n-fold different and more fantastic and marvelous than your own. Things that will be fundamentally new and magical and different, that if you saw them today, you wouldn't believe them, you couldn't possibly comprehend how they work. And then their children, who of course Kurzweil think is the last generation. So you live in this unique event in history that's never happened before, where innovation is at such an incredible pace that change is so unpredictable, but we can detect this climb that these forward-thinking people are looking at, these singularities, right? What happens when it's going straight up? When the rate of change is ungovernably fast, what do? What happens? What's the ramification? That's, in my mind, one of the root causes of their concern. This is the evolution of compute power over time, Moore's law, et cetera, et cetera. The point being is we're sneaking up on the compute power of the mouse brain. We'll get to the kitty. We'll get to the 2-year-old probably in your life, right? And these are autonomous learning entities, right? Do they have souls? Do they have consciousness? Well, they're certainly going to be self-aware. there certainly you'll never want to play them in chess. The chess masters gave up, right? They're not playing chess against computers ever again. There's no point. Can't even get close. Beating us in Jeopardy. They're getting very, very smart. So we're sneaking up on that guy, the human brain, which is okay. Really, our collective brain is the big thing that will get superseded. That is the singularity that's the concern. So I'm an old sci-fi guy, and I kind of grew up on Isaac Asimov. And he wrote the series I, Robot. His premise was that these would be thinking machines, and there should be governance. So this was his primitive, imagined governance, right? That a robot may not injure a human being, or through an inaction allow a human being to come to harm. The second law is that a robot must obey orders as long as it doesn't supersede the first rule, and the last rule is that it shouldn't harm itself as long as it doesn't supersede the second or the first rule. So there you go. Is that going to work? There's your governance model. A little thin. Let's talk a little bit about the other one. So in the autonomous car sector, obviously highway hands-free, right? Because it's a relatively unambiguous situation, right? There's not a lot of clutter. There's a couple of, you have to do lane detection, you have to do radar front, radar back, right? It's a compute solvable problem in enough real time to make it doable. The next thing is a bumper-to-bumper hands-free. You're going to start to see that rolling out in the models, probably 2018, 2019. Bumper-to-bumper bumper-to-bumper hands-free. Once again, it's not very ambiguous. You're stuck in traffic. You're just sneaking forward. You got to not run into the guy in front and back. And they're doing all kinds of calculations to help you figure out what lane to be in, and they'll put you in the right lane, and they actually do lane balancing across the things. And then, of course, parallel parking. Once again, why can machines do parallel parking much better than you ever could? It's precise, and it's a very finite space. So the trolley parable, the trolley dilemma is the automated vehicles rolling down the track, and the track splits. And do you go to the right and kill a bunch of people, or do you go to the left where they're working on the track and everybody on the trolley dies, right? Moral of the story here is, if you look at the Google Car Sim, do they turn left and run over Granny in the wheelchair, or do they turn right and squish the kid on the bike? You got to code it. What's the car going to do? If it stops, somebody's going to smash you from the back. My point is that this is getting coded. It's getting written into software in unambiguous terms, right? So, anybody here believe in God or believe in religion? Why do you believe in things like religions, right? Usually it's because it's a moral constraint framework. It's a moral framework that helps guide decision making. It's supposed to be a gauge, a metric. You're either white, black, or gray in terms of your moral ambiguity. That's what religious constructs are often about, right? It's a model for making decisions. Well, we're coding that in. We have to. We're automating this stuff, so we're coding that in. I don't have any other great realization other than that, yeah, thank you. That it's not, this codification of this logic is getting increasingly subtle and sophisticated, and it's not the geniuses of the world who are writing this code. It's just the software engineers, right? No offense, but it's China. It's China, India, Bosnia, Russia. They're writing this code. I'm not saying that's bad. It just is what it is. So the other sector that I play a little bit in is healthcare. And the big thing in healthcare is we're getting old, right? We're getting old. And there's not enough young people to take care of us. There's more of us than there are you. So we're doing this. We're putting robots in place. Everybody who's working on the cutting edge of aging in place, so you don't want to put the old people in the homes. It's much more cost effective, and it actually is more life fulfilling if they can stay home. But we don't have enough people who can go visit them and take care of them, so we're automating, right? And we're trying to do things like the big cuddly teddy bear, right? So that it's not so totally creepy, even though I think the big teddy bear is pretty creepy. This is going on, right? So this is going on. So we're putting sensors in the floor, sensors in the couches, sensors behind the mirror, sensor in the refrigerator door, so that we can keep track of what's going on. And we're having the elderly wear bands, and we can tell by their motions whether they're going to the bathroom enough or they're getting enough activity, but we can actually tell with the micro movements, because it's enough data over enough period of time, the corpus is big enough where we can tell if they're depressed or not by the little movements in their arm. Then there's the autonomous economy. The financial sector has always been enamored with quants, right? The silver bullet quant, right? The algorithm is going to beat the other guy, and that's going to make a ton of money. And this has been going on for a long time. So they're early adopters of this stuff. And you see it in the form of automated trading, and the amount of trades that are actually automated trades is getting bigger and bigger. You know how many tweets are done by people? 60%? Political tweets, 1 in 10 is human. Tweet bots, right? And you can't tell it. You can tell. With another machine learning algorithm, we can tell. So all I'm saying is, one of the most powerful forces in the management of the world economy, the ebb and flow of money, resources, and the fate of our economy is increasingly being pushed off into algorithmic management. Pretty good. And then there's work itself. We went through the Industrial Revolution, and the big fear is that, no one would have jobs, and we kind of moved over and we went through the information revolution, and that was the same fear again. But it's risen again, that as we go through this next phase in automation, that we are automating out not just blue-collar jobs, which we did in the manufacturing sector. There's a political push to bring manufacturing back to the United States. It's like, dude, were you not paying attention? That's robots. It doesn't really make jobs. But anyway, we're automating professionals, and there's a swing in the futurist economists who are really concerned. There's just not enough work. There's just not enough work to go around because we've automated it out. So that's just a fundamental kind of law of physics in the economic sector. There's not enough work in the future. And then there's the avatar. So avatars were introduced primarily in the gaming sector, but I ask you to think about this in this way. So there's the information that you willingly provide to the internet, right? You fill out the form and say, yeah, I'm going to buy that. And you've got name, address, phone number, or whatever you've contributed. And then there's another sphere out, which is a bigger sphere of what information is out there in the world that's just been detected. You didn't necessarily opt in, it's just been watching you. And that's got a profile. You talk to the online advertising guys, they have 2,000 data points on every individual in the United States that they got from a heterogeneous bunch of sources, which they use to do data mining and to put you into a cluster of profile so that they're pushing the right product or service in front of you and helping you navigate, right? Because they're trying to get the most amount of money out of you as they can. And beyond that, there's what they think they know about you, which is an even bigger sphere of information, right? And so some of the first avatar services that we're seeing out there are not virtual people. They're rather services that are watching your digital entity information that's out there in the world already and trying to give you some control, proactive, as opposed to passive reactive thing, but a more proactive action in managing the information out there in the world. So if you go and apply for a job, they're going to search the internet and find out everything they can about you. There's all kinds of services that do that. There's counter services arriving that can detect that this is going on and can put you in the best light, right? There's all kinds of situations where we actually want to clip the information that the world knows about us out of the information sphere. Like if you're being bullied and you want to disappear a kid, right, from that sphere so that they can track down the bother. So the first avatars you're going to start to see in the next few years are services that you can subscribe to that help protect, manage, and maintain the digital information sphere that now is a representation of you into this world. But I thought this was an interesting thing I stumbled across is the robotic body is a copy of the human body remotely controlled. What they're thinking is going to start to happen is, and I'm partly bionic, right? I've got metal parts here, metal parts here. Eventually you get whittled out and it's just the brain and you've got a robotic skeleton. The next phase beyond that is your whole neurological representation migrated out of the brain and into a silicon neural net representation of you and your personality. And then beyond that, I don't know where you go. It's just you live. We have done the matrix at that point.
Do you consider these dates anywhere near possible? None of them
No.
seem anywhere near feasible.
No.
Based on this. Nowhere near it.
No. You know, but the dates always surprise you. It happens in weird little spurts as opposed to these big massive fronts, and we're always surprised by the dates. I mean, back in the mid '80s, we were predicting in the CYC that the big push back then was common sense knowledge domain, right? Yeah. Because most of our logic systems and our knowledge automation systems were very domain tight, and we were very smart about a very specific thing, but they were very brittle and didn't deal with ambiguity well. So they tried to develop these big general open source linked networks of common sense knowledge, right? Yeah. It gets dark, it's going to rain, stuff like that.
Just these nuclear fusion, right? It's been 40 years, I've been saying it's 5-10 years out, and it just, there's factors of it, and like the thing that bothered me about the second one, right, was we don't know how to pull data from a nerve accurately, let alone the entire
I think, and I totally agree, that the thing to watch are the little autonomous breakthroughs, right? And they're not even little. I mean, there's big sectors that are going to be disrupted because of the innovative automation and enablement of autonomy. That's what the self-driving car is about. That's why Uber's all in, Google's are all in, because these guys got huge war chests of money and they're throwing it at this problem because it's a significant problem and it's potentially solvable. So they're going all in on autonomy. The financial guys are going all in on autonomy because they want decision making to be made in real time based on huge factor sets, and so they're trying to push that autonomous decision making out to the edge.
And I guess what I've been grappling with through this presentation is that definition, right, of the perception of AI versus, so when Elon Musk talks about AI, right, he's looking at it differently, because he's asking for regulation on an industry which he's leading, which is rare for a person to do that. But then you get into these situations where the arc you showed going up, right, and then the computer chip, right. So with the computer chip transition, like I question, is a binary computer chip capable of doing the type of AI that can program itself and get into ethical questions and deal with beyond just an algorithmic kind of process, more like the brain. Now there are things like cognitive, you had them listed, right? Cognitive computing, DNA computing, synaptic computing, which start digging into the areas which may be able to be quantum, right? Which may be able to cross into those when together. But that's where I kind of grapple with how close we really are. I mean, we separating the difference between AI that Google's doing now and Tesla's doing from like the scary AI where they're making, and it's gray area, right? But the type that people consider when you say movie AI.
And obviously we're using it, right?
Yeah.
One of my slides said, look, it's all around you. It's these nice little algorithms they're doing. They're basically doing cluster analysis and categorization. And then from that, they can make derivations, right? We can look across large corpuses of data and say, you fit in box A and you fit in box B, and they could be fuzzy boxes because of multi-dimensional stuff. So it's happening across many industries in little point solutions. The big all-encompassing, get it all together thing, where we have broad consciousness. The thing to watch is the unsupervised learning folks.
Yeah.
They're trying to plumb the depths of what does it mean to learn, and trying to automate the process of learning. For example, the 2-year-old hand on the hot stove, they know. They've got a little minor back brain PTSD thing that says they only need one event, and they have learned not to touch the hot stove. They're super good, right?
Yeah.
What was the mechanical construct around that single event learning? And that's what okay, and I know this is a long roundabout way of talking about it. So that's one thing that's very interesting to me. And the other one is the deep learning mechanism. So the deep learning is a tree, a hierarchical tree of neural networks, where at the base level it can do things like recognize light and dark, right? They've come up with a neural net construct that can recognize light and dark. And above that, enough of those assembled together, they can recognize a line. And enough of those above that, they can say, oh, that's a circle, or that's a square. And a little bit above that, they can say, hey, that's something that has wheels. And one thing above that is that's a motorcycle. And that was all constructed with unsupervised learning corpuses, right? From the bottom construct up. And I think that's what's going to really accelerate things, is because we have these really increasingly large corpuses of data, and we've got enough compute power where we can crunch the hell out of it with all kinds of model iterations and tweaks and tunes on the model to find the optimal model convergence, that we have these self-assembling units. Yeah. And when you get self-assembly and autonomous learning, right, where does that go? Yeah. And I think that's what people are a little bit squeamish about.
Yeah, and I guess the difference.
And when does it happen?
Yeah, that shift is tough, and I'm not sure. I don't know enough to know where it triggers, but the thing, like, I was talking with some of the Watson guys recently, and the difference that they state, right, is when people think of Watson as it's just answering questions, it's like a human thinking about it, but in reality,
they think
it's
of it as
doing
a unified
statistical
thing
analysis of data in a specific field, and you've got to choose a corpus that matches to its function, and then what's interesting is they make the distinction, right, that it has the knowledge, kind of the information and the ability to retrieve stuff that like an engineer would have, but it's not going to make the connection on, well, the problem, I looked at all that data and I came up with a creative solution on how to solve the problem. Like, that's not what it does. And that transition is where you get into something that goes beyond that. Like, that we aren't doing algorithms that do that.
Yeah, so the Tensorflow push by Google is interesting. They took the construct of an assembly hierarchical neural net construct, and they said any node doesn't have to be a neural nexus. It can be any algorithm. Yeah. And it's an assembly topology. So given that you've got enormous compute power for pennies a cycle, and you've got increasingly open linked source data, as well as IoT sensor data is going to proliferate, and we're going to have enormous corpuses to grind on. Mm-hmm. And we've got these increasingly cloud-centric algorithmic resources available to you, and they're low-level tools, right? I mean, we're talking kind of flint knives and bearskins phase of this, right, level of technology, but they're just putting it out there and say, please play around, because they're looking for people to connect the dots in new and interesting ways. And it's you come out with your knuckles are all bloody and you finally got this thing working in it. It solves that equation. And then the model drifts, because data is not static. Data drifts over time because the world that the data represents is drifting over time. And what people do is they converge on a model that is an accurate enough representation of the thing that they're trying to predict, and then it drifts in terms of its accuracy over time. And we're starting to see people looking at that model drift as a vector of change, as an early indicator of a vector of change, right? Second order derivative, just the model itself drifting. So once again, it's kind of a long-winded thing. I think there's this weird assembly hierarchy, and all the tools and pieces parts are in place, and people are starting to plug them together and solve some pretty cool problems. We've been working on natural language processing for a really, really long time. It's a really, really hard problem, right? And it just recently got good enough. And it got good enough in algorithmically surprising ways. Right? We were surprised.
Yeah.
And we got to 92% recognition in an unsupervised learning set.
Yeah.
Yo.
The thing that kind of fascinates me a bit here is that the machines are learning, they're imitating human beings, like you were saying on the slide. You said that the call center, you've been talking to a robot and you think it's a human being, they get into that point. At what point then, when the computer mimics the human so much that the human thinks it's real and assigns a life form to it and maybe even legal rights, whereby it's still just a program? A very good one, but a program nonetheless.
Hey, people anthropomorphize all kinds of stuff. We've been talking to our cars for a long time. We talk to our pets. We talked to Ashley Simmons at the Director of Innovation at Florida Hospital. You know, the studies they're doing with sensor technology in the home to help the aged, where, hey, you forgot to turn off the sink, or hey, the lights are still on, or you know, you should really get up right now and go in the refrigerator and get some juice. People, these folks start to anthropomorphize that instantly. They give it a name, they talk to it, they say, thank you, you're welcome. You know, they have complete conversations with these agents.
But do we still consider a life form? Because, and I say life form and not a person, because if it's in the cloud, that's not physical.
They're going to sense, they're going to make decisions, right? They're going to learn. You know, we're creeping up on something.
I think you have to look inside yourself.
Or wait for them to decide about viruses first.
Maybe they're going to
We
decide.
are the virus. They'll get rid of us in a heartbeat.
Yeah, well, you know, that's kind of where you get, right? Right. If it's in the world's best interest for us to be here or not, right? This is kind of my summing up. Is AI adoption, sophistication is speeding up. I think we see that. It's kind of a given. I think it's an economic imperative. The benefits of this avalanche of automation is so strong in terms of business imperatives. I don't think anything stops it, and I think it moves faster than any government constraint. Government constraints usually follow, regulations follow, just because they didn't know any better. You know, they're rarely ahead of it. So that any kind of thoughtful constraint trying to maintain civilization as we know it will lag behind the innovation curve, in my opinion. Decision making is being coded into every system and every product. So everybody is expecting every new toy to be smarter and smarter and smarter. And smarter converges on something that they can interact with and communicate with and have a relationship with. Decision making overlaps ethics and will become autonomous. So what is the moral precepts that these decisions are going to be made in light of? The forward thinkers are concerned. To me, this is a canary in the coal mine when the really smart forward thinking guys are going, ah! You know, I pay attention. And so they're doing that. You know, we really need to pay attention to why they're concerned. And, you know, just evolution continues. You know, where does this go? It is a survival of the fittest machine that we've created and that we're creating. So where does that head? You know, fire beware. Yes.
What is the worst case and best case scenario in the next 25 years or so?
Yeah, I would think that that we've got enough help that we eliminated a lot of the most horrible things that go on in life, and that, you know, that we have leveraged these capabilities to, you know, kind of have a full, rich, and round life in a humanist sense, you know, based on rationalism. In my mind, that's the best case. I think the worst case is clearly that they run us out.
So nonchalant.
25 years?
Put it mildly.
Snuff us out.
25 years we're getting snuffed out by machines? That's the
Oh,
prediction?
I don't think it's 25 years, but what does it matter?
26.
All right, so, you know, at some point you kind of got to talk about DNA, right? DNA is a big string of code. The immortal thing in DNA is the gene. The genes have this construct of self-replicating. We're a side effect of that, right? We're a vessel. You know, it's code. Where's that going to go? What happens when so a lot of people are working on DNA as a storage mechanism, and DNA is the compute mechanism. So it doesn't necessarily go silicon carbon. It could just, you know, yeah, we're code. Where do you live? You know, the thing that we attach our being to is this construct of, you know, this layer set of conscious thought. That's what we associate ourselves with, right? There's entities, there's loci in your brain that separate you. Its job is to separate the you-ness from the world of experience you're around. So when people take LSD, that thing gets turned off. I'm a cosmic universe. That's what happened when you took LSD. All I'm saying is, if that thing that's keeping you together is increasingly understood, does it migrate? Does it become code? Does it just get coded? You still are alive, you're still aware, you know, there's that. So the leap to immortality is either the thing that is your neural network gets migrated over, or, you know, the telomerase ends on the DNA, we figure out how to keep those from self-obsolescing and, you know,
Reproducing.
yeah, you just never die. You know, and they're talking,
Or you die and then you just get
yeah, you get rebuilt.
re-replicated,
Yeah, you get
3D
rebuilt.
printed out, and you're good to go.
And it's, you know, we missed it by, you know, arguably 2 generations is what these people are saying. Or not, you know, it depends on yeah.
So, I'm gonna critique your, graph earlier, the purple one with the line going straight up. I think it's a little bit misleading, and I would like you to respond. Showing it in just like that kind of flat and straight up, that doesn't necessarily say anything specific about the actual technical skills going into being made. So the knowledge base that it requires. So if you took the volume base of someone 6,000 years ago and wrote it in a book, and you took the knowledge base of someone creating this and wrote it in a book and compared those books, would you say that that graph is an accurate representation of that kind of skill base? And from an anthropological perspective, if you're looking at the effect on society, this is the current revolution as far as like looking at removing jobs from the wild is comparable, I think, to the mechanical revolutions or revolutions in the past, but more exact comparisons, I think, would garner more interest in the dilemmas in that field than how it often gets narrowed down to is like you have all of this happening right now and then kind of like, well, the rest of this was nothing or very slight. So,
Well, I mean, you know, we're getting better at understanding what the big leap was, why we're here, and you know, you guys can understand me kind of, sort of. We can share concepts and ideas. I mean, we had bipedalism, we had fire, we had stone toolkits, we had all the constructs. We're the same human bodies that we have been pretty much for a long, long time, 150,000 years. But about 60,000 years ago, something happened. And that group of people spread and rubbed everybody else out. There were 6 sapient species on the planet at that time, 60,000 years ago. All gone. They're all gone. Parts of them we inbred, right? What happened? The thing that they think happened is that we are able to share symbolic constructs, right? We're able to invent abstract, shared symbolic concepts like money is an abstract concept, or government's an abstract concept. We can go on and on and on. Then we invented writing, which, you know, shared symbolic constructs were as good as we were able to pass it on by word of mouth. But then we had this thing that was more persistent. And then there were some other technical innovations that allowed that to be more widespread, printing. And then you get into computers, et cetera. All of these things have to do with broadening the base of shareable knowledge and persisting that knowledge and being able to stack that knowledge so that it's more integrated. And that's that ramp. That's what's fueling innovation. We have access to, one of the talks I gave recently, at the level of the dorm room, they can cloud compute and have access for pennies, huge algorithmic constructs, as well as open source data.gov, right? At the dorm level. That used to be a vastly multi-million-dollar engagement. I don't see that slowing down. So we're stacking up we're enabling all of these movers of that innovation curve. And now we've thrown a new consciousness into it, a new compute construct, right? That increasingly is working at that mesoscale communication level, right? You and I are talking at a certain tier. There's a tier below us which has to do with, all the details of, all the engineering that went into this, and this. We're not talking about that, and we're not talking about metaphysics per se. We're talking about this mesosphere. Well, our computers are now being able to communicate with us in that mesosphere architecture that we live in. And I think that's going to accelerate things as well. That's why I say to people, stop working on UIs and start working on
The skill of the jobs that are being replaced is the biggest difference as well. I work in healthcare as well, and robots are doing surgery every single day now. Every day.
Because they're
Major
precise and
surgeries.
dependable
My
and
company
reliable.
has a robot that can do a complete total knee replacement. All robotic. It looks like the surgeon's doing Nintendo Wii. And it's growing very, very quickly. We have cameras that can identify vital organs so that you don't accidentally nick a liver or something like that in a laparoscopic surgery. And eventually there's a company out of Canada that actually learns what the surgeon's technique is. So if the surgeon is on surgery, say 6 for the day, and is tired and starts deviating a little bit, it will say, hey, doc, you don't normally do this, what's going on? And it will help correct them. And eventually that technology will get to the point to where they're using those cameras that can identify certain organs. It'll get better and more specific, and those programs for very basic routine surgeries that are stuff we see all the time, you won't even need a surgeon in the room. It'll be a circulating nurse. And
I think we're going to see within the next, just a handful of years, a lot more activity in the area of advisors and monitors and mentors.
But that's
things that are
replacing-
tapping you on the shoulder. They're not taking complete control, but they're saying, ow!
The largest growth sector in healthcare right now is healthcare IT, because there's a lot of change right now, and the places where you can affect the most change, efficiencies, cost, outcomes, everything, is AI-based things being able to predict. This person has this symptom, and this symptom. Most likely, the next thing coming is this. Let's treat it before it becomes a thing, and we keep them out of the hospital altogether. And if you can do that, then you win.
That's been
We're getting
We're getting the boot.
We're getting the boot. But are you going to be?
Surgeons better find a new
I
job.
actually have a dinner thing.
Kind of
Okay.
across everywhere.
Well,
Just
we'll
think
make
about it. The trash
speculation
guy.
about
The trash
Well, I
so you don't need that
certainly
trash can
enjoyed
anymore.
talking,
It's like
and
every industry.
talking to you, and I
How it
enjoyed all the
Yeah,
questions and answers. I have a
the
stack of
biggest
cards up
difference
here
is
if
the
anyone
level
wants to
of
reach
skill.
out to
You're
me
replacing
later.
somebody that took
Classes.
Yeah, thank you very much for the opportunity to share my concerns.
For those of you who came in late, I just We turn it over to Harp and Kel, which is like a bar, it's right over that way. And, you know, we can talk deeply about, you know, how AI is going to take over or not take over. That's what I know. Thanks.
Yeah, I gotta go find some Dale's contact information. Coffee.
What is your what's going on?